Screen now?
Yes, sir.
Yes, sir.
Yes,
Okay.
yes, sir. We can see this one.
Okay. So we'll start. Huh? See at this view you can you see? Hello.
Yes, sir. We can see, sir. We can see this view.
Sir. Yes, sir.
This Vivek Kumar is trying to enter. Is he in our group? This Vivek Kumar.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Should I allow him?
Yes,
हाँ
sir.
सर.
Yes, sir.
Okay, he has entered. I think. Yeah. Okay. Okay. So let us start. See, in this class, basically, your in your syllabus it is written as soil mechanics 2, if you see. Okay. However, soil mechanics 2 is basically related to foundation engineering. It's just the next part of soil mechanics. So whatever you have studied in your fourth semester course soil mechanics, it will be related to that and it will be extension to that. So basically, as part of the prerequisites, we'll start with we'll start with the thing which is basically your basically soil mechanics and foundation engineering, and we'll start with shallow foundation. Okay. Now first of all, before getting into foundation engineering from soil mechanics, first thing you need to understand why we require a foundation. First thing you should understand. So foundation, you see, foundation, as you understand, it is the base part of any structure, because from any structure, whatever load a structure needs to carry, that load needs to be transmitted or transferred to the ground level using some component, and that component is basically foundation, which you have understood during your introduction to civil engineering course during third semester maybe, as well as you have understood it during your soil mechanics course in fourth semester. Okay. Now coming to the foundation engineering, why we as civil engineer we need to know about foundation engineering, and what is the relation between soil mechanics and foundation engineering, that you need to understand very clearly. The first thing is, see, soil mechanics. In the soil mechanics, you have studied about mechanics of soil. That means how the soil will be able to take up different kinds of loads, that you have understood in soil mechanics course, as well as you have studied about the properties of the soil. Basically, you have studied about the properties of the soil in your soil mechanics course, and while studying about the property of soil, you have understood different things like your shear strength of soil, and you have learnt about the shear strength parameters of the soil. So if you see shear strength of soil and shear strength parameter of soil in soil mechanics course, you have learnt about two parameters called C and phi. C is basically the cohesion of soil, and phi is the angle of internal friction of the soil. So if a soil is a purely kind of sandy soil, then the angle of internal friction will be there and there will not be any cohesion. And if a soil is a purely clayey kind of soil, then there will be only C of the soil and there will not be any phi of the soil. But most of the soil, if you see in the nature, will be mix of C and phi. That means it will possess some cohesive property, as well as it will possess some frictional property. So considering that, if you remember that Moore Coulomb failure theory or Moore Coulomb failure envelope, where there was a straight line drawn between your shear strength and shear stress, basically shear strain and shear stress. Or if you draw draw a diagram between your C and tau, then you have got an equation C. If you have got an equation that tau is equal to, where tau is the shear strength of soil or shear stress in soil, is equal to C plus sigma tan phi. So basically C is the cohesion of the soil and phi is the angle of internal friction of the soil. So if you plot between shear stress and normal stress, then there will be a straight line, and that straight line will define the strength property of the soil. Now this strength property, how it will be useful in foundation designing, that you need to understand in this foundation engineering course. That is the primary objective. Okay. Other than that, you have also learnt about permeability of soil, you have learnt about compaction of soil, you have learnt about consolidation of soil. So consolidation is another one characteristic which will be very useful in foundation engineering. And the concept of consolidation, if you remember, to find out basically the settlement of the soil. So the settlement of the soil, if you want to calculate, then you will have to remember and go back to the prerequisite of your 4th semester course of soil mechanics, where you have learnt about the consolidation of soil. Okay, and these consolidation parameters also will be coming into picture when you will be learning about the settlement of foundation. Now going forward, let us start with foundation and see the first slide. Say the shallow foundation. So before going into shallow foundation, let's try to understand what is foundation engineering. So everyone can see the slide what I am sharing. Can everyone see?
Yes, sir.
Okay. So just a minute. This one, if can be tried. Just a minute. This one, if I can draw. This recording thing is not going away from the screen. Anyway, you can see now, right? So shallow foundation. So before getting into shallow foundation, let us discuss about foundation engineering. Now what is foundation engineering? First thing you try to understand. So you see, foundation engineering is nothing but art of selecting. It is an art. The engineer will decide on foundation. So basically it is an art of selecting, designing and constructing the elements that transfer the weight of the structure to the underlying soil or rock. So it is the job of the foundation engineer who will decide on which kind of foundation he will have to design. He will have to select it, which kind of foundation. Then he will have to design it, and then he will have to construct it. So all the three jobs needs to be done by foundation engineer. So that is very important. So foundation engineering is basically the concept. It is a concept where you need to understand about how do you basically how do you select a foundation, how do you design a foundation, and how do you construct a foundation. All the three things are the requirement of a foundation engineer. A foundation engineer must know all these things. The second thing is the role of a foundation engineer will be to select the type of foundation. The type of foundation. This type of foundation is very important to understand. Which type of foundation you will be applying for which kind of structure, which kind of soil, that you need to understand. and its design and the supervision of the construction. All of you know that the lowest part in every structure, in most of the cases, the lowest part of the structure is generally referred as foundation. And the function of the foundation is nothing but to transfer the load of the superstructure to the soil. That means a foundation is sometimes termed as a substructure. So, a substructure means the substructure will be taking the load from the superstructure, and superstructure is nothing but your structure which you see outside the ground, and that superstructure will be transferring the load to the foundation, and in turn that through that substructure, that superstructure load will be transferred to the soil on which that substructure is resting. That is very important to understand. A properly designed foundation, first you must understand this very clearly. A properly designed foundation is one that transfers the structural load throughout the soil without overstressing of soil. So, this term is very important, overstressing of soil. What do you mean by overstressing of soil? Overstressing of soil means the point I have just told you 2 minutes back, that shear strength of soil, shear stress of soil, that Mohr Coulomb failure theory, that is tau equal to C plus sigma tan phi. So, tau is the shear strength of soil. So, your soil should not be coming to a stress level which will be overstressed. That means, if the superstructure load which is being transferred to the substructure causing a stress at the soil level which is more than the tau, that is the shear strength you have calculated for the soil, if it exceeds that amount, then you will be overstressing the soil, and in such case, because of the overstressing, your foundation will fail. So, a properly designed foundation should be such that the structural load should be transferred to the substructure level and then through the substructure to the soil without overstressing the soil. So, as a foundation engineer, it's your role, it's your job to find out how you can make the foundation in such a way that soil will not be get overstressed. And I again emphasize on this point that overstressing means it should not exceed the allowable shear strength capacity or the allowable shear stress in the soil, which you can obtain using the simple equation, that is tau equal to C plus sigma tan phi, where tau is the shear stress in soil which it can carry because of the two shear strength parameter, that is C, which one is, first one is your cohesion, and the phi, the second one is your angle of internal friction, and another one parameter is there, that is sigma, that is actually the normal stress which is coming onto the soil. Okay, and the second point you see, that line I am reading again, a properly designed foundation is one that transfers the structural load throughout the soil without overstressing of soil, which can result in either excessive settlement or shear failure. So you see, the first part we have understood, that overstressing of soil means it may create the shear failure of the soil. And the second thing, it's very important to understand, again I have just spoken 2 minutes back about consolidation, if you see. So, the consolidation, whatever you have learned in your 4th semester course of soil mechanics, that consolidation deals with the settlement of the structure, right? And that settlement calculation is also very, very important. So, your foundation should be such a design that it should not be excessively settling. If it goes beyond the settlement limit, then your foundation will fail. So, you should be very cautious about these two criterion while designing any foundation or while selecting any foundation, while designing any foundation, while constructing any foundation. So the first thing is the selection of the foundation, then you will come to the design of the foundation. So what do you think, what are the different kinds of loads can come on the foundation? The first thing you see, the dead loads, live loads, wind loads, earthquake loads, these are the different kinds of loads always will come on the foundation. So the dead load, how does the dead load will come onto the foundation? See, all the superstructure whatever is constructed, that will have some dead load, and in turn those dead load will be transferred from the superstructure to the substructure, and the substructure is the foundation, and ultimately that dead load will be transferred through the substructure to the foundation soil level. Next is the live load. Live load means whatever is running on the structure. That means, let's say people are moving on the superstructure, then you have some kind of different kinds of furnitures on the structure, you have some kind of moving things on the structure, you have machineries on the structure. So all those things will be coming under your live load, and those live loads also will be transferring the load from the superstructure to the substructure, and ultimately the substructure will be transferring that load to the soil. The another two important loads which you must consider for while selecting and designing a foundation, that is wind load and earthquake forces. Now the point you may ask, that why wind load and why earthquake load? Because you see, wind load and earthquake load both are the kinds of load which acts laterally on the structure. So, and you see foundation, if you model a foundation and total structure, you can see it will just behave like a cantilever. That means a foundation is just inside the ground, which is fixed inside the ground, and the superstructure is standing outside the ground. So if you think that wind is coming from one side, then what will happen? The structure will try to bend, right? The structure will try to bend, and the moment will be getting generated at the foundation level, and because of that moment there may be a case of toppling of the foundation. So those kind of wind forces needs to be considered while designing the foundation. Exactly the similar way, if you consider the earthquake forces, that is the seismic forces, then seismic forces also will basically create some kind of lateral movement of the foundation, and those lateral movements will ultimately create some moment at the foundation level, and that moment needs to be registered by the foundation. So your foundation needs to be designed for those kinds of moments also. Next type of load you see in different cases, you will find that foundations are subjected to different kinds of lateral pressure. So lateral pressure exerted by the foundation earth on embedded structural element, that also you need to consider. So lateral pressure means, if you think about a retaining wall, if you have noticed that by the side of the road, whenever there is a kind of underground outlet or some kind of things, then you notice that two walls come out from the two sides of the road, and those two walls are generally called, these kind of walls are generally called retaining walls. And you see, those walls will be subjected to huge amount of lateral pressure from the soil itself, and that soil pressure will be trying to topple the foundation on which those kind of walls are constructed. So such kind of inclined thrusts also needs to be taken care while designing a foundation. Next is the uplift forces. So if you see, the uplift forces are very important to be considered, because uplift force will come onto a foundation whenever you see the foundations are constructed, any foundations which are constructed underwater. So you see a jetty foundation or a dock foundation where the foundations are constructed on kind of underwater construction, then there will be some kind of uplift force coming, and those uplift forces also needs to be controlled by foundation. Next is your dynamic forces, and dynamic forces are very important to understand, because you see dynamic forces, if you do not dynamic forces if you see, dynamic forces are nothing but the forces coming from the machine foundation. Okay, so machine foundation, let's say you have constructed a building on the ground floor level. Let's say you are putting lot of machineries on that, so the machineries will be, while it will be running, that machineries will be creating huge amount of what you call vibration kind of force, that is actually dynamic force. So your foundation needs to be designed for those kind of dynamic forces also. So basically, if you see the general requirement, if you consider the general requirement of any foundation, if you see the general requirement of any foundation, it needs to support the superstructure load, and ultimately that superstructure load needs to be transferred through the foundation to the soil level. And while transferring this load through the foundation to the soil level, you must be aware about two facts. That is actually the general requirement of a safe foundation, that the 2 points which we have already discussed, that there should not be excessive settlement and there should not be excessive shear failure. You got it? There should not be excessive settlement and there should not be excessive shearing of the soil. So basically, while considering or while designing and selecting a foundation, you must be very cautious about the fact that you cannot basically allow your foundation or the soil underneath the foundation to be failing by shear failure. And failing by shear failure means, because of the load coming from the superstructure to the foundation level, the foundation should not be the soil under the foundation should not be getting overstressed, such that the shear stress, whatever the soil can take, that is being exceeded by the load which is coming from the superstructure to the substructure. And the second thing is, the foundation along with the control of the shear failure should not be getting settled excessively. Means if the foundation is staying safe in shear also, then also you will have to notice that foundation is not getting settled excessively. And for this settlement of foundation, you need to remember your previous semester course soil mechanics and the consolidation settlement of foundation, where you have learnt about immediate settlement, consolidation settlement, primary consolidation and secondary consolidation. We will discuss more in detail while we will be discussing about settlement of foundation in this regard. Okay. Now going forward, let us go to the next slide. So let's see, this is your now let us come to foundation, shallow foundation. Now classification of foundation. First thing you should understand, classification of foundation. How can we classify the foundation? All of you can see it, or should I make it larger?
Sir, make it larger.
Is it okay now? Is it okay?
Yes, sir.
Yes. So you
Yes,
see
sir.
the classification of foundations. If you see, foundations can be broadly classified under two categories. One is called shallow foundation and the other one is called deep foundation. So, and the definition wise, shallow foundation and deep foundations can be understood depending on the depth of the foundation. That means at the bottom level of the foundation, depth of the foundation means the bottom level of the foundation at which depth from the ground level, that is actually the depth of the foundation, and the width of the foundation. See, every foundation will have two criteria. One is the width, that is the breadth of the foundation, and length of the foundation. In most of the cases you will notice that while designing and while analyzing the foundation or while setting up the foundation, the primary criteria will be the breadth of the foundation, and this breadth of the foundation will be taken as the criteria for deciding whether the foundation is a shallow foundation or a deep foundation. So, the foundation, if the foundation depth of the foundation or depth of the footing is less than or equal to, the depth of the footing is less than or equal to the width of the foundation, then the foundation will be called as shallow foundation. That means if the depth of the foundation is df, if the depth of the foundation is df and the breadth of the foundation is b, then if df is less or equal to b, then always we will be calling those kind of foundation as shallow foundation. On the other hand, if the depth of the foundation is more than the width of the foundation, that means if the df is greater than the b, then we will be considering that such kind of foundation as deep foundation. Now, categorizing the shallow foundation again into different parts. So, category wise shallow foundation again can be broadly classified under two categories. One we will be calling as directly footing. Basically both are footing, but one will be specifically calling as footing and the other one will be called as calling as raft. I am coming to raft later on. So, let us say what is a footing. So, footing, you have noticed just as a single column is coming down and on the bottom of it you are creating a foundation. So, such kind of foundation will be called as footing. Now, this footing can be of again of different type, that is spread footing, then strap footing, then combined footing, and the spread footing can be again divided into two categories, isolated footing and strip footing, and the combined footing can be categorized as rectangular footing and trapezoidal footing. So, let us try to find out from the figure. You cannot see this figure, right, or you can see the figure?
So not properly.
Figures you cannot see. This recording part you can see, right? One recording
Yes, sir.
window
Yes.
is coming.
Yes, sir.
I am not able to understand why this is not going from the screen. Just give me 1 minute, okay? I will see if I can just remove it somewhere from here. Just a minute. This is coming at the top. How do I? Just a minute. Anyway, this is not going now. Let me just share again. Okay. Now can you see the figures? Now can you see?
Yes, sir.
So let's see. See the diagrams. I don't know why this is not going. Let me try. It's not going at all. It's coming to the next slide again. But if I just increase the size, will it go? Let me check. No. Now you can see little bit larger.
Yes, sir.
Yes. So see, footing when we are talking, see we are telling about spread footing, strap footing, combined footing. Okay. So see, this is actually spread footing. Spread footing means which are basically spreading. So spread footing means this is your column. See, this is your column. You can see this is your column, So see, just below that column a footing is given which is spread across the total dimension of the column. So this kind of footing we will be calling as spread footing. Okay, so this is a spread footing. So this total thing is spread footing. So you see, on this if you notice, this spread footing, if you see this spread footing, this is actually rectangular or square in nature. On the other hand, you see this spread footing, this one if you see, this is actually circular footing. Okay, on other hand, if you see, there is another one spread footing on which there is a wall, continuous wall is going, and underneath that there is a footing, and this kind of footing we will be calling as strip footing or continuous footing. Have you understood now? So basically footing, if you consider, that means a shallow foundation. When you are talking about a shallow foundation, we can talk about footing and raft. So footing means kind of individual columns coming on a spread area, or one or two columns coming over a spread area, and that kind of spread area we will be calling as spread footing, and that spread footing can be isolated footing and strip footing. This isolated footing and strip footing, you see, the individual column, under the individual column, if there is a individual foundation, that means at an isolated level, if there are foundation, then we will be calling them as isolated footing. On the other hand, if a footing is continuous under something, that is some kind of a wall footing, under the wall there is a continuous footing, such kind of footing we will be calling as strip footing. On the other hand, you notice these two footings, this one and this one. See, two columns are carrying on a single footing. You see, two columns side by side are given on a single footing. So can you notice it? So see, this kind of footing we will be calling as combined footing, because multiple columns, that means more than one column, two columns basically, two columns are being placed side by side on a footing, and this kind of footing will be called as combined footing, and these combined footings can be of rectangular type or it can be trapezoidal type. So you see, when it is rectangular type, then you can expect that the load coming from the superstructure to the substructure is equally distributed among the two columns, and you can put a foundation underneath which is rectangular. On the other hand, you see, sometimes it may happen when on one side there will be lesser load and one side there will be more load coming onto the column. So two columns, if you want to place together, and when the two foundations are overlapping on each other, then what you will have to do? You will have to combine it. And in such case, if at one side there is lesser load and on the other side there is more load, then you may have to go for this kind of foundation, which is kind of a trapezoidal foundation. And the last part, if you see, the last part of the shallow foundation, that is raft foundation, if you see, this is a kind of raft. Okay, and this raft is nothing but, you notice, it's just as kind of a slab. So if you want to construct multiple columns, and where the bearing capacity of soil, where the carrying capacity, I will not say bearing capacity now, where the carrying capacity of soil is very less, in such case, if you want to construct a shallow foundation, in that case you put a raft underneath the structure, and raft is nothing but a slab, and on that slab, a thick slab basically, and on that thick slab you construct multiple columns. Okay, and once you construct multiple columns on that, on the above, on top of the slab, then such kind of foundation will be called as raft foundation. Now coming to the deep foundation. So what is a deep foundation? I have explained. Deep foundation is nothing but a foundation where the depth of the foundation is more than the breadth of the foundation, and this deep foundation can be again categorized under various types, that is deep footing, pile foundation, pier foundation, caisson and well foundation. We will get into the details of these at a later stage. Okay. Now see the next slide. If I go, you see the next slide. See, how do you select then a foundation? How do you select? So steps, what are the different steps you need to carry out for selecting a foundation? So see, here is the point where you need to understand that the soil mechanics and foundation engineering are correlated, because if you do not know soil mechanics, you will not be able to do the foundation engineering. So steps for selecting foundation type, if you want to select which kind of foundation you will be selecting, for that first thing what you need to know, you need to obtain the required information concerning the nature of the superstructure. First thing, for designing or selecting any foundation, you need to know what superstructure that foundation needs to support, whether it will be supporting a 10-story building, 3-story building, 5-story building. That beforehand you need to know. Otherwise, how do you understand how much load will come from the superstructure to the foundation? So first information concerning the selection of any foundation, first thing you need to know is the nature of the superstructure and how the load from the superstructure will be getting transmitted to the foundation. See, a simple two-storied building, which will be used for residential purpose and which will be used for some machine installation, just like lathe or something some different kinds of machine, the requirement of foundations will be different. That you now must understand. Okay, because a two-storied building, so when it is used for residential purpose, the load requirement, of the load which is coming from the superstructure to the substructure will be different than when different machines are placed on the same two-story structure at two floor levels. Because of the placing of the machines, there will be vibrations coming onto the foundation, there will be dynamic load coming onto the foundation. So your design criteria, your selection criteria, your type of foundation may differ for a same two-storied building depending on the usage of the building. You should be very, very careful about it. The next is, you need to obtain the soil investigation and subsurface soil condition. So this is where is the importance of your soil mechanics. You see, you need to first know how is the soil, what is the soil, is the soil is cohesive, is the soil is purely cohesive, or it is a C5 soil, or it is completely sandy soil, what is the C value of it, what is the phi value of it, what is the permeability of the soil, what is the consolidation characteristics of soil, how does the soil compact, what is the liquid limit of soil. All these things you need to know, otherwise you will not be able to design a foundation, or you will not be able to select a type of foundation. So these are very important. So now you understand what is the relevance of soil mechanics with foundation. So you need to know, you need to do sieve analysis of soil. So you will have to collect the soil from subsurface level where you are trying to construct foundation and test the soil for different characteristics. So characteristics of strength you will have to test, characteristics of settlement you will have to test, other different characteristics like its water content, its water limit, its liquid, its different consistency limits, its permeability, everything you need to check. Otherwise you will not be able to give the proper idea about the selection of type of foundation. Now next is, decide on the bearing power on the soil to carry the required load. And what is the bearing power? I have explained it. See, bearing power is nothing but not to overstress the soil. So you will have to find out how much the soil can bear. It should not exceed the limit of the bearing of the soil. That means the amount of shear stress the soil can take, the load which will be coming from the superstructure should not exceed that. The next is decide on the adverse effect of the structure due to differential settlement. So settlement is one part. So you will have to think about settlement of foundation, but along with that you will have to think about differential settlement. And what is differential settlement? Differential settlement means, suppose one part of the structure, let's say 4 columns are there in a structure. Let's say only one column, the foundation under one column at one side is settling excessively, and other columns are just resting on the foundation exactly at the same level. So what will happen in that case? The differential settlement will happen. Differential settlement means one side will be getting down too fast and the other side is staying at the same level. And when this kind of condition is happening, then it will become under differential settlement condition, and this differential settlement condition is too much detrimental for a foundation. It will not detrimental for foundation, it is too much detrimental for the superstructure. But because of the differential settlement, there will be severe kinds of cracks may be getting generated on the superstructure, and there may be a high probability of failure of the superstructure. So based on the above, if you consider all these conditions, you will have to considering all the above conditions, you will have to explore the possibility of construction of any type of foundation. Okay, so you will have to explore the condition for exploring the foundation. So basically in that case, you see what the point I try to make here is, without knowing the soil parameters, without understanding the soil characteristics, as a foundation engineer you will not be able to do anything. So before you become a foundation engineer, you need to learn soil very properly. You need to have clear idea about the soil mechanics. So soil mechanics is such an important subject for foundation engineering, you now understand. Now next is after you have decided on the possibility of construction of foundation. Let's say if you are seeing that your foundation, your bearing capacity, while not bearing capacity, I should say the carrying capacity of the soil, if you see that carrying capacity of soil is too less and the load coming is too huge, then you may not go for a shallow foundation. That means if you put a shallow foundation, then what will happen? At that level soil will not be able to bear it, and thus the foundation will fail. In such case you may have to go for a raft foundation. If the raft is also not a proper foundation, then you will have to go for deep foundation. So you will have to go for piling or pile foundation. So these are the conditions, these are the possibilities you will have to study while designing or while selecting the type of foundation. So based on, make more detailed studies after everything has happened. Then you need to make more detailed studies about the accurate load determination. So see, all these things are conceptualization. First you will have to conceptualize the thing, because unless and until you conceptualize, you cannot go for detailed study, because you will have to tell your client which kind of foundation he may go for, and that kind of foundation will be safely doing for the structure he is expecting. So you will have to suggest the client first that, and then after that you will have to go for more detailed studies and more detailed studies about the load determination, that means exact how much load will be coming onto the structure. So accurate load calculation from the superstructure is very important. And then you will have to more detailed study about the subsurface conditions. You will have to do subsurface conditions means where you will be constructing your foundation at the ground level, at the underground level, where you will be putting your foundations. From that level you will have to collect soil, you will have to collect the sample of soil, and then you test it and check the condition of the subsurface, and then you will have to decide on the footing sizes and type of foundation. And also along with that you will have to estimate the settlement of the foundation. If you do not estimate the settlement of foundation, then your foundation design may be totally failing if there is excessive settlement of foundation. So foundation settlement criteria you need to always check before deciding on any foundation, and then finally estimate the cost of the foundation. Okay, so you will have to give the client a solution which will be safe enough, which will be economic enough, and which will be done based on the accurate calculation of load determination from the superstructure, as well as the study of the condition of the subsurface. So see, the problem in our Indian scenario is this, that people always talk about structure, okay, they try to construct structure very strong. They put lot of cement, lot of bricks, lot of what is called reinforcement. They think that if they put lot of these things, then everything will be safe. But if you go and tell a person that sir, you are putting it so much things, but you spend at least 5% or 10% of cost for investigation of the soil, you will see the resistance from the client. They will see, oh क्या आप soil test करके क्या होगा, अरे लगा दीजिए, उधर आसपास वाले घर में सब चल रहा है, आपका क्या, आप क्या बोल रहे हैं, बाजू वाले सब घर तो ठीक से खड़ा है, यहाँ पे भी चलेगा. And with these assumptions only 70% buildings are constructed. But no, that should not be the case, because you don't know that what is the soil condition where you are trying to construct your building or where you are trying to construct your structure. See, the problem is this, that you don't know that 300 years back whether where you are constructing the foundation there was a pond or not, or that has been filled up with some kind of material or not. Just beside seeing the buildings standing beside the area, you cannot predict on the soil condition of that area. So while constructing a huge structure or while constructing any structure, ideally you must check for the soil condition. So subsurface condition testing is a must while doing any kind of structural construction. And without subsurface condition testing, one should not go and select a foundation, as well as one should not design a foundation without getting the subsurface condition data, real data of the subsurface condition from the soil mechanics lab. Okay, then ultimately finally what you do, finally decide on the type based on the optimum performance level with minimum cost. That is what I was saying you, that you will have to do it with maximum performance level. Basically your performance, every client will want that performance will be maximum and your cost will be minimum. So that performance based thing you must be doing while means minimum cost level and maximum performance you must be giving for your designing. Okay, so basically you see the general observation what you need to make before any foundation construction. There are two observations you must make, you must do. That is, soil you see does not possess a unique linear stress strain relationship. If you remember the soil stress strain behavior while you have studied about shear strength of soil in your 4th semester course, you see the strain versus stress curve of soil is not like steel, it is not like mild steel, it is something different. So it does not follow a unique or kind of a linear stress strain relationship. So because of that, you need to cautiously understand about the stress strain characteristics of soil, and then depending on the time, environment and behavior of the soil, you must construct your foundation. Okay. Now next is soil at every location. If you see, the soil at every location is essentially different. That is what I am trying to tell you just 2 minutes back, that you cannot say that बाजू वाला घर ठीक से खड़ा है बोल के ये यहाँ पे भी कंस्ट्रक्शन ठीक से चलेगा. No, it may not be the case. Soil at every location is essentially different. So nearly in all the cases, the mass of soil involved is underground and cannot be seen entirely. So you cannot see the soil, you don't know what is there in underground. See, just 500 meters away you may get a rocky stratum, but where you are constructing your foundation, you may not be having such kind of rocky stratum. So depending on that foundation, you cannot decide on a foundation which you are constructing at some location. And next is, you must see the last thing, that is that most soils are very sensitive to disturbance from sampling, and thus the behavior measured by a lab test may be unlike that of in situ soil. This is very important. What does it mean? That means when you collect the soil sample, you should be very cautious about collection of sample, because while collecting the sample itself, the soil strength parameters get a little bit disturbed. So either you will have to take care about the disturbance, or what you will have to do, you will have to take help of some in situ testing. In situ means at the site only you test it. Okay. So you have learned about standard penetration test in your 4th semester course. Standard penetration test, anyone? Hello.
Yes, sir.
Standard penetration.
Yes, sir, little bit.
Standard.
Yes, sir, little bit.
Little bit. Okay. Yes. So standard penetration test, if you see, that standard penetration test is a kind of in situ test. So it gives, without collecting the sample also, it gives from the driving of the hammer, it gives some idea about the soil. So in situ soil sampling and collecting should be very cautiously done. Otherwise, the soil is so sensitive material. If you cannot collect the soil sample properly, then your testing will be wrong in the lab, and you will be coming up with different soil parameters which is not resembling the characteristics of soil on the ground, and thus you will be landing up with a wrong foundation type selection and design. So you should be very cautious about these things. Okay. So I think I should stop here today. So I have tried to give you the brief overview about foundation. What is the job of a foundation engineer? Why do you require foundation engineering, and what are the things you need to consider for designing a foundation? And the most two important criteria I have explained, that for any foundation design or any foundation selection, you will have to consider the subsurface soil condition, you will have to consider the superstructure load which is coming from the superstructure to the substructure, and the third thing you will have to consider the two criteria which are the most important criteria of any foundation design, that is the condition of shear failure of the soil and the condition of excessive settlement of soil. So with this I stop today, and in the next class we will be moving forward and we will be discussing more about the shallow foundation and how the shallow foundation basically fails in shear. We will be discussing in the next class. You can see this slide. There are different types of failure in the soil of shallow foundation. So there are different types of failure of soil. We will be discussing in our next class tomorrow. Okay. So is it okay? So if you have any question,
Yes, sir.
you can ask. Okay. So anything?
Yes, sir. My question is actually लास्ट सेमेस्टर सॉइल का सारा टेस्ट उतने अच्छे से हो नहीं पाया था, ना ही लेबोरेटरी में, और थियोरेटिकली भी मतलब थोड़ा सा कंफ्यूजन बहुत ज्यादा रह ही गया है। तो इस सेमेस्टर में वो सारा कुछ कोरिलेटेड है, तो थोड़ा प्रॉब्लम हो रहा है। तो वो चीज भी एक है, और दूसरा चीज की कोई बुक आप अच्छा सजेस्ट कर देते जिससे सारा एग्जाम्पल्स ज्यादा होता।
एग्जाम्पल?
यस सर, ताकि मतलब
हाँ।
क्वेश्चंस ज्यादा बन पाए और थियोरेटिकली भी, ताकि अच्छे से क्लियर हो जाए।
हाँ, books I will suggest tomorrow. Okay, I'll give you some books. Okay, and we'll try to find out some e-books for you through which you can refer. Okay.
ओके सर,
E-books.
ओके सर।
Huh? Because in this situation the problem is you cannot just go and buy books also, right? So that is the problem.
यस सर।
Na? So we'll have to go for some e-books kind of thing. So we'll try to find out some e-books. Now you just follow this lecture notes, because till now we have not started with main course. Okay, main course will be starting later, little later. Okay, now you just go through this, whatever we are telling, whatever the classes are being done, you just follow those.
ओके सर। यस
Okay, and books let us try to find out. Okay.
Yeah.
Who is this Umesh Kumar Datta? Now why is coming, trying to come? I don't know.
Hello,
Okay, so
Sir.
please हाँ, hello,
sir. What is inclined?
बोलो, हाँ बोलो.
Sir, inclined thrust क्या होगा? Inclined thrust.
Incline. Okay, incline thrust. Incline thrust. See, incline thrust means, see, suppose you are putting a foundation. Okay, just एक example देते हैं. देखो, have you noticed that while constructing any kind of drain, have you noticed drain का construction observe किया? उसमें देखना, while constructing a drain, when the concreting is being done, see the scaffolding is done from the outside. Okay, and while doing it actually you will notice that one kind of support is being placed on the scaffold from the outside direction in the inclined direction, and this kind of thing is basically putting pressure so that it does not come into the, it does not fall inside. So tomorrow I will give you one example, diagrammatic example of inclined thrust. Okay, so it is it is difficult to explain. I will give you one example, diagrammatic example. Okay, the Umesh Kumar Datta, who is this Umesh Kumar Datta? Do you know him?
Yes, sir.
यस सर।
He is from our
Yes,
class.
sir.
So admit. Why he is coming now? Subhadeep Chatterjee. Why there? Okay. Anyway, so let us stop today. Tomorrow again we will discuss going forward.
Okay,
Okay. Okay. Thank you.
Thank you, sir.
Thank you for joining. Okay.
Thank you, sir.
Thank you, sir.